Hello everyone, welcome to Chapter 6 Part 1. Chapter 6 Part 1 we are going to walk you through the process of solving a problem in Excel using the central limit theorem within normal probability distributions. The problem we are going to tackle is problem 10 in section 6.5 of the text. It's the Mensa problem. I highly recommend that you spend some time in the text reading on normal probability distributions and central limit theorems. That'll help you to understand why we're doing what we're doing and why we solve the problem the way we do. I'm simply going to take you through the process of solving the problem. The problem states that membership in Mensa requires an IQ score above 131.5. 9 candidates take IQ tests, and their summary results indicated that their mean IQ score is 133. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. To solve problems in this particular area, you're always going to need a standard deviation, they're going to need to be normally distributed, and they're also going to give you the mean. Once again, Excel has a handy function to solve problems like this. I'm going to go ahead and put Chapter 6, Problem 10 within Section 6.5. Section A, Part A of the problem. If one person is randomly selected from the general population, find the probability of getting someone with an IQ score of at least 133. Alright, so we're going to use the norm distribution. And you see it tells you what you need. You need the x, the mean, the standard deviation, and the q. So the x is the number that they give you that you're going to solve for, the problem for which they're asking, the number about which the problem is asking. They're asking about 133. Okay, we know the mean is, because it's given to us, is 100. The mean score on IQ test is 100, and the standard deviation is 15. In this particular case, we are looking for a cumulative function. You can see here that it gives you a little instruction, and you can see on my screen on when to put a 1 and when to put a 0. In this case, we're going to put a 1. And we get an answer of 0.9861. What this is telling us is the probability of somebody scoring, of all the population scoring between 0 and 133. What we need is the probability of somebody scoring more than 133. Since the normal distribution function in Excel can't do that directly, we have to find the probability of everybody. That's why it was cumulative. What's the probability of someone in the population scoring between 0 and 133, and now to find for more than that, we subtract from 1, and we get the probability of 0.0139. So about 1% of the population will score 133 or above. All right, problem B. Now they're going to throw us a little curveball. If 9 people are randomly selected, find the probability that their mean IQ score is at least 133. So how does this really change the problem? Instead of finding one person who's 133, we're going to find the probability that 9 are 133. Have probability of 130. Have a mean of 133. So what this really does is it affects the standard deviation. The more participants you get, the higher the number, the lower the standard deviation gets. So in this case, to properly adjust the standard deviation, we are simply going to take the number of participants, equals 9, and we're going to divide it by the square root of the original standard deviation. And do square root, simply type in SQRT, parentheses, 15, which was the original square root. And that is our new standard deviation. So now what we're going to do is re-enter the previous information, and we have a new standard deviation, so we're going to reference that cell. Once again, hit 1. We're going to hit, and the answer they give us is 1. And then we're going to take 1 minus that number again, which of course 1 minus 1 is 0. So the probability of 9 randomly selected people having the IQ score of at least 130 to 3 is mathematically 0. Which means it's probably, Excel is designed to at some point just round off. So that the actual probability is probably a very, very long decimal number, but the Excel just takes it to 0 in this particular case. So then problem C says, although the summary results are available, the individual IQ test scores have been lost. Can it be concluded that all 9 candidates have IQ scores above 131.5 so that they are all eligible for Mensa scholarship? And the answer to that would be no. What we have calculated is the probability of all of their scores relative to a mean of 100. So if the mean is, if they're asking if things are above, can we say because there's such a, it's such a rare occurrence for all these folks to have a mean of 133, or be 133 above, it would be calculated very differently in association to 131.5. So they're trying to trick you a little bit here. Because everything's been calculated in reference to 100 rather than 131.5. And of course 131.5 is much closer to 133. So you could not make that jump and that they would all automatically be eligible for Mensa. So here we'll just say no. All right. We'll see you in the next part of Chapter 6. Please contact me with any questions.